Hi friend, today I am going to talk about system call in Linux, especially how the system call actually is implemented for ARM. Generally, if you read the books, you can always find how it is implemented for x86, but as we all know that many of the developers are working on ARM processors, so it is also important for them to know how it is implemented. It will definitely help them in debugging. Friend, so what system call does? So let me recap. So it provides a layer between hardware and software. So if you want to read something from the disk, or you want to read from any flash, as a user you should not worry about it. So you have to simply use the POSIX provided API, read, and then you can do it. Here in this presentation I am going to talk with reference to read API, and when I say libc_read, so basically it is read function definition inside the library function. And also I would like to say that when application calls the libc, and libc actually calls the supervisor mode instruction to go into the kernel mode. So this is how this SVC instruction is how we go in any OS from user space to kernel space. System call number is see, whenever actually we have to call the system call, basically we have to pass the system call number, and using this particular number only we have to identify which system call has to be called. So what happens actually, if when the moment we pass the system call number, the system call the vector underscore SWI, which is in kernel address space, basically verify whether this particular system call is possible to be inside this the list of system call or not. And also it has further, which I am going to talk further. So if you look at the slide, the application calls the read function, and then read function the moment actually it calls the supervisor instruction, it goes into vector underscore WI, then it will call the system to read, and then read will return the pointer, and then vector SWI will go back to libc_read and application. Here I am going to talk about how exactly it works. So let me take you to the next slide. So libc_read. So libc_read does two key things. One, it loads the system call number into R7 register. So if you see in this line 21192, you will see that the location, whatever the content of the location 211D0, that is 3, is getting loaded into R7. So it if you see the 3 number, so 3 is nothing but the system call number for read. In the similar way, if you can see the system call number for other system calls as well in the below provided link. Once it will load the system call number, it will call the SVC0, which switches the user mode to kernel mode. Okay, and also it calls the one of the function in vector table, that is vector underscore SWI. So here vector SWI has some role to do. It actually gets this system call number, which is in R7 basically, and then using R7 it try to get the actual address of the in the system call table. So how it does, actually, if you see this instruction, add any SCNO. SCNO is nothing but system call number, and R7, and then this particular system call base is getting added, so it will actually give the address of the function. Then we will load the system call table, and then again, along with any system call function, we have lot of parameters also, arguments also, so we have to save those arguments as well in stack pointer. And once it's done, actually we will invoke the system call on this particular address, which is nothing but this is underscore read address, and then it will do all the operation in system underscore read and comes back. And in the similar way, it will come back to libc underscore read, and then libc underscore read will do the operation vxcclr, so it will go back to main, and the entire system call will be performed. I hope things are clear for you. If you have any question, do write me at exebinary@gmail.com. Thank you.